All right, all right, all right. Okay, so this will be our second video on research methods for AP Psych. Again, my goal here is to take the 45-minute live reviews that AP is doing and get them to you guys in much less than 45 minutes, but still have the content be meaningful. Hopefully, you have been able to watch some of those videos, whether live or kind of more on demand or replay. I mean, they're very informative, right? I mean, they do a really good job getting that information across. So I highly encourage you guys to. They want the phone. Highly encourage you guys to check those out. Okay. So second one on research methods. Going to start off with the variables. We will look at three kinds of variables. We'll go independent, dependent, and confounding. So to start with independent variables, that is basically also known as like the treatment, or maybe the treatment that is being tested or studied. So pretty much anything in a question that is being tested or studied, that is the independent variable, right? So if you think about something like caffeine, right? So a study might be, does caffeine improve racing performance? Does caffeine improve test scores? Studying, right? Does studying increase test scores, right? Does a pack of fruit snacks before a race improve performance, right? So caffeine, drugs, the impact of studying, right? Those are all independent variables in these examples, right? So again, it is also kind of called the treatment. It's typically what is being tested, what is being experimented on. If you drink 8 ounces of coffee, then ... will you set a PR, right? Will you score better on the ACT the second time, right? So the 8 ounces of coffee is the independent variable, and the result, right? What you are measuring, what you are learning, that ACT score, that new time on, I don't know, like a 2-mile run. Those would be the dependent variables, right? So if I do 30 minutes of studying every night, will my A go to an A plus, right? So the 30 minutes of studying being the independent variable, and then whether my grade goes up or not depends on that independent variable, right? So the independent variable is going to be sometimes basically what the researcher is doing, right? The group, the psychologists who are performing this study, this experiment, they choose, and we'll get into a lot of this stuff later, but they can choose, who is getting 8 ounces of coffee, who's getting 6 ounces of coffee, who's getting no coffee whatsoever, who's getting a placebo, right? That puts them under the impression maybe that they're getting caffeine. So the independent variable is something that the researcher does, something that the researcher maybe manipulates, and the dependent variable is not, right? Dependent variable is just you. So any question that would ask to distinguish, who is receiving the independent variable, right? Who is receiving the caffeine? Who is receiving the note cards for studying? Who is receiving the drug on, for COVID vaccine? Who is receiving that is called the experimental group, right? They are the group of people, whether they know it or not, and whether the researcher knows it or not. We'll get into the blind studies, but those people receiving that drug or that caffeine, they are being experimented on, so they are the experimental group. So dependent variable kind of introduced it a little bit, but the dependent variable is also going to be called the result, the data, the measurement, right? So when you took that caffeine, what was your 2-mile time? When you took that caffeine, what was your grade on the test? When you took that drug, did your COVID-19 symptoms go away, right? So it is the result. That is completely dependent on what happened with the independent variable, right? So the result of the things being tested, the result of the caffeine, the drugs, all that kind of stuff, that those are all the dependent variables, right? So the independent variable is what the researcher does, what the researcher manipulates, and the dependent variable is what the researcher learns, what the researcher gains in understanding as a result of the experiment. And a little bit to confound, haha. A little bit more complicated with the variables would be the confounding variable. So most often is going to be unintentional, right? Sorry. Could be coincidental, right? Could be an accident. It's not intended by the group doing the research, right? So now why you have to study it though is because it can directly impact or influence the dependent variable, right? Whether intentional or not, it can throw off results. So we need to be able to understand that. And researchers, those doing the experiment, they want to limit confounding variables as much as possible, right? So the more control they have over the study, the less likely there is to be a confounding variable or variables. And that is important because, as I'm sure you guys know, that allows the results, the data, to be all the more valid, right? All the more accurate, because the data hasn't been confounded, right? Hasn't been complicated. So essentially it's really difficult to get perfect experiments. It's really difficult to have total control over everything, and it's really difficult to foresee any possible confounding situation that might arise, right? So you might hear this called, again, probably more in the multiple choice section, but you might imperfect experimental control. But that's basically what allows confounding variables to happen. If you guys remember back from class, our really fun, exciting example of confounding variables was blank and blank. Give you a couple of seconds here. Did you get it? Did you get it? Yes, perfect. Murder rates and ice cream sales, right? So for whatever reason, as they were doing this study, as murder rates were increasing, and we'll make it, let's say Springfield, as murder rates were increasing in Springfield, places like Cold Stone and Baskin Robbins and Culver's, they saw their ice cream sales increasing as well. And, it's silly, but you might think that the two are directly related, right? That either murder, set something off in the murderer's head, says, I should go for ice cream after I commit this murder. Or you have ice cream, you have Cold Stone, and then you think I should go commit murder. No, we know that not to be the case. It was a confounding variable, right? And that confounding variable was, give you a few seconds. Did you get it? Did you get it? Perfect. Yeah, it was the heat. It was the summertime. The heat, 90 degrees, whatever, is forcing people to lose some of their inhibitions, forcing people to make some decisions they would make, maybe be a little more irritable, and murder rates increase. And nothing goes better on a hot day than, a bacon peanut butter concrete from Culver's. I'm not sure if they have something like that, but they should. That would be really good. Something that is unforeseen, something that if you don't look in more detail, you would think, those two were directly related. They're not. Another example, really easy would be ice cream sales and drowning rates, and it'd be the same thing, right? So you might see that as you study, as ice cream sales increase, so does the rate of people drowning. And again, it's summertime, it's the heat, and they're not related whatsoever. The more control you have, the less confounding variables are likely to arise. And again, the more accurate your data, the more valid your dependent variable is going to be. It's really difficult to be very precise in identifying causality if there are confounding variables, right? So you might think, yes, ice cream is forcing people to commit more murders, but correlation does not mean causation. Say it again, correlation does not mean causation. And I'll say it one more time. Correlation does not mean causation, right? Because of confounding variables. We know, it's silly, but again, we know that, the independent variable, dependent variable, aren't always going to be directly tied, like ice cream sales, murder rates, that stuff, because of confounding variables. The other thing I'd talk about today would be the placebo effect. You guys all know what that is, but basically placebo effect, it kind of goes back to main characteristic and the Hawthorne effect, that when you know you are part of research, when you know you are taking this pill, or when you know you're getting this shot of caffeine, your mind, kind of plays tricks on you, so to speak, that you all of a sudden start acting more energetic because you think you just took this shot of caffeine, right? And it's really important in psychology to study because it shows the power of the mind, right? But it's really important to identify, in those people receiving the placebo would be in the control group. You have control over their results because you gave them the placebo, right? So it doesn't matter for them. It doesn't really matter in a sense what their test score is, because you didn't give them the caffeine, right? Or you didn't give them 5 note cards versus 10 note cards versus 15 note cards to study, right? So this placebo effect, it's really important because it can help kind of, tie in and kind of solidify some of the results. But again, it's really interesting. It's really neat because, you give someone a pill and you tell them, hey, this pill is designed to make you more energetic. And really that pill is just a placebo. It is not an energy pill whatsoever. Sometimes you might see those people act like they have more energy, right? And sometimes I think it's, something that's kind of well known, whether parties or media or movies, whatever it might be. But, same thing when, it's probably getting, we'll share the story. But when we went to, we were fortunate enough to go to state when I was in high school, and we lost our first game at state, and the parents were kind of celebrating anyways. And one of the moms on our team, so the story goes, she had been drinking margaritas, that they had made it at the hotel. And I guess she was acting pretty drunk and was very loud and laughing, uncontrollably. And, some other signs of, I guess, drunkenness. And someone was asking her about what she was drinking. And she said, margaritas. And come to learn that they actually just had the margarita mix, just the flavor, strawberry or whatever, but there was no alcohol in it. But she thought she had been drinking tequila or margaritas or whatever it might be. And really she had just been drinking more or less sugar water or flavored water. And she let it get to her head, I guess, and was acting drunk. So that's kind of a placebo effect there, where she thought she was taking it and she really, wasn't having any alcohol whatsoever. And so sometimes, you use that placebo to try to help learn a little bit more about your results. See here. And that helps with the validity of the experiment, the accuracy of the experiment, when you have your experimental group, and you have your control group, and you can have a placebo group as well. Anything else? Again, going back to Hawthorne effect and demand characteristic, real quick, we'll kind of finish here pretty soon. So demand characteristic, Hawthorne, remember that just when you're being watched, or when you've taken a drug, you tend to behave differently. And so that can kind of skew the results a little bit. And because of that, because we don't want people to be acting differently, because we want people to be very natural, because we want, valid data, that you use a single blind study in which, the people in the research have no idea what they're taking. They don't know if that coffee is strong, weak, or decaf, right? They don't know if the pills they're taking, whether it be drugs for COVID-19 or whether it be caffeine pills, they don't know if there's actually caffeine in there, or they don't know if it's a placebo, right? They have no idea what they're taking. Double-blind study is when those people don't know what they're taking, but the researchers also don't know which people in the experiment are taking which pill, right? And so single blind kind of protects against the Hawthorne effect and demand characteristics, but the double blind allows the researcher bias to be eliminated, that they didn't, if they have bias, if I want to prove to you guys that yes, studying absolutely will make a big difference, you have to go home and you have to study for 30 minutes every night, right? And I'm doing this experiment on it, right? And I really want to prove a point because I know my hypothesis is correct, that I will, instead of randomly selecting people, and we'll get to that later, but instead of randomly selecting, who gets to study, who gets to study just a little bit, who gets to study a moderate amount, and who gets to study a ton, and then who doesn't get to study whatsoever, to make my bias become reality, I will choose the smartest kids in the class, and I will give them 30 minutes of study time, right? And I will take the not so smart kids in class, and I will give them no study time. And so when I get the results, it's going to show, because the smart kids got to study and the not so smart kids didn't get to study, it's going to show most likely, right, that that I was right. The researcher, see, look, here's what smart kid A got on the test. Great job, and it's because they studied, right? And here's what not so smart kid didn't study at all, and see, they didn't do as well. So to protect against that kind of bias from happening, there's the double blind study, right? And so me, the person in charge, I don't know who's getting, what COVID-19 drug or what caffeine pill, or a hot cup of decaf versus a hot cup of espresso. I don't know, whatever has a lot of caffeine in it. So I don't know that kind of stuff, so it helps eliminate bias. And again, it's going to get into random assignment and random sample and stuff like that. I don't want to give you guys too much though, so we're going to stop right there. So we have the independent variable, right? What is being tested? The amount of caffeine, the amount of studying, the COVID-19 potential treatment. Dependent variable, which is the measurement, the result of what the researcher learns, right? So test scores went up, or the treatment eliminated all symptoms of the COVID-19, right? Or the 2-mile time improved, or it didn't improve, right? So it's what I am learning. Confounding variable is accidental. It's something that impacts the, maybe it looks like it creates correlation. It could skew the data. It could impact the dependent variable. And the more control we have, the less confounding variables will arise. But a lack of experimental control, and you're going to have, confounding variables popping up. And because of things like the Hawthorne effect, where we behave differently when we're being watched, and demand characteristic, which is essentially, when the experiment is about, the impact of caffeine, you might all of a sudden start acting, right, placebo. You might all of a sudden start acting a little more energetic. Because of that, we have to use the single blind study. Those participating have no idea what they're getting. And to eliminate research bias or experimental bias, we have to use the double blind study, in which the researcher doesn't know and the person receiving the treatment doesn't know. So we're going to cap it right there. Hopefully it wasn't too long. Hopefully you are taking notes as you go. I do have an important FRQ here assignment that I'm going to send out, and we can discuss those results, or what you guys write down, on Wednesday. We can answer any questions you have on Wednesday. I am going to send out another video here in regards directly talking about the FRQ and my advice on how you should attack that sucker. Okay. So thanks guys. Talk soon.